Good evening. Good evening, everybody. My name's Arthur. For my sins, I run the data science practice at RBC. I also run the location intelligence practice, and we look after third-party content and a few other interesting bits and pieces as well, not least of which is all the climate change analytics. So I've been asked to do a little bit of a talk to you, and I'm going to get waved at if I move too far here. We thought we'd talk a little bit about location intelligence, a little bit about GIS, and a little bit about how a location intelligence product might evolve. But before we do that, really have to talk a little bit about location intelligence. Before I leave this slide, that picture in the right, whoops, wait, here we go. Look at that. That picture on the right-hand side, that was my first office. So before you think about getting into location intelligence, keep in mind there are snakes at the beginning of it. Absolutely true. Yeah, that's in outback Australia. You can see the eucalypts behind there, and one of my team sitting inside. That was my first office. I spent 3 months there. So, question for everybody. Are you familiar with the movie Captain Phillips? These Somali pirates would come out from Mogadishu and the northeastern shores of Africa, and they would attack commercial vessels that were coming by, hold them to ransom. They'd get somewhere in the vicinity of $3 million ransom. They'd kill a few of the crew, and they'd hand the vessel back. So we were approached, knowing that we know a little bit about location intelligence, we were approached for a solution to this particular problem. Anything that we could show this three-letter organization from the US, anything that we could show them that would help them in fighting the piracy. So we said, sure, give us all the data. We were actually, I'll tell you the story in a moment, but we were actually able to identify something that made a substantial difference to the way that the piracy was managed and handled. And if you saw the movie shows the way the pirates operated after we'd given the information over. So we had a fairly dramatic impact. Over here, this is one of the patrol, it's an inflatable from one of the patrol boats, and you can see just in the background here, that's the skiff that the pirates operate in. So the way they would work, so here's, oops, I'm not allowed to move out of shot. This is Mogadishu, that's the capital of Somalia, and that's where the pirate vessels were leaving from. And their practice was to go out in these little skiffs, these 20-foot, 28-foot skiffs, and they would board a merchant vessel and then take it over, basically take it over. And then, so this would happen basically in this region. These dots are all the attacks that we track. So what we were able to establish was that along this coastline, there is actually a strong ocean current. And the strong ocean current is the reason that the shipping channel's there in the first place, because they're taking advantage of the extra impetus that ocean current was yielding. So the pirates knew about this, and so what they would do is they would come out from Mogadishu until they felt that the current was moving them, turn everything off, and just wait for a vessel to come along. When the vessel came along, of course, they'd attack it, and that was the end of the game. So what we were able to just say, well, we see this behavior, we see that they're taking advantage of this ocean current, and so they changed their patrol practices to catch the pirates before they caught the merchant vessels. As a consequence of that, this is the end of the story though, as a consequence of that, what actually happened was that the pirates got wise to it, and instead of going out in these little skiffs, they would go out in a mothership. If you remember Captain Phillips, there was a mothership, and then they would launch the skiffs from the mothership. And in case you're interested, the information that we were given by this three-letter organization from the US, the information we were given included transcripts, included pictures, video, scanning information from the radar, tracking information from all the vessels. So we had a lot of information to work from to deduce that this current was in place. There was one instance on tape where a merchant vessel was being escorted by a US destroyer, and one of these skiffs came out to attack the merchant vessel, but they were so close to the merchant vessel they couldn't see there was a destroyer behind the merchant vessel. So they opened fire on the merchant vessel, and the captain of the destroyer radioed the merchant vessel captain and said, "Hard astern, we're going to deal with these." And they they went full throttle round the front of the merchant vessel, and you would think the pirates would turn tail and flee. Instead, they fired on the destroyer. Big mistake. So the captain put a round across their bows. They still fired on the destroyer. Captain said, "Sink it." And they took a Gatling gun, 6,000 rounds a minute, and they cut the bottom off the skiff. Just carved the bottom right off it. And then they rescued it. The unfortunate corollary was that in 2 weeks later, those same pirates were out in another skiff. It's sad. So, location and GIS. There are two terms here in play, and you've probably heard both of them. There is a difference between the two of them. But before we do that, let me have a go at defining GIS for you, and then we'll go on to location intelligence, which is where my passion lies. GIS stands for Geographic Information System. It's the old style of handling geodata. You've probably seen products like Esri, that's a GIS product. And I'll talk a little bit more about the characteristics of it, but where it all started, this is the very, very first map done by GIS. Does anybody know the story of John Snow? No? Dr. John Snow. In 1854, there was a cholera breakout. Okay, I've got some nods. Folks are remembering it now. There was a cholera outbreak in London. And John Snow, on a hunch, plotted all the occurrences of the cholera disease breaking out, and he plotted all the locations of the wells. Symbology is pretty straightforward. You've got outlines of parcels, you've got contours, all layered up. So that's the idea of GIS. So now comparing location intelligence and GIS, Asan asked me to go into this just a little bit, so we'll walk through this story. Before I go into the story though, this at the bottom here is a screenshot from the GIS system that I use. I actually started the GIS and I took this screenshot. This is the operator bar across the top here, and some of them have got pull downs. Now some of them are not active because I didn't turn certain pieces on in my data set below. But can you imagine how long it would take you to learn what all those do? So that's one of the problems with GIS. It's obscenely complicated. It's exotic, it's esoteric, and the practitioners, it's sort of a black art from the because that's a little more obscure. So we don't want obtuse languages. We don't want complex setups. You know, the standard GIS install, apart from the one that I'm using actually here, it can be quite complicated. There's considerable infrastructure required for it. At one point, the GIS specialists were all claiming that, oh, you have to have a geographic information officer as well as a chief information officer. And that stopped after a while. Whereas location intelligence is conceptually simple. And you can take one definition of it. It's all about proximity. Anything that's near anything else, that proximity means something. So if I move away from this camera, my proximity to the camera is reduced, and Amir over here is starting to panic because he can't see me anymore. If I walk up closer to it, proximity changes. So it's all about thinking about proximity, and it's thinking about what the proximity means. That's the way to think about location intelligence, and it's literally that simple. Some of the pieces that we use to execute are a little bit more obtuse, but you know, it always boils down to that. And I've got some examples for you. However, there is an issue with this, the location intelligence business, because there is a tendency for the GIS world to leak over into the location intelligence world, and we don't really want all that complexity impinging on our space. And the other problem, of course, is there literally, if you look with Google, location intelligence product, you won't find any. You might find some GISs, but you won't find a location intelligence product. And that's why in the bank we've spent quite a bit of time building the foundations, because the foundations are not easily found. I'll spend a little bit of time with this. I think everybody's probably familiar with the hype cycle. Everybody knows what the hype cycle is. I've got a few nods. That's great. The principle of it is pretty obvious. This is the hype cycle from geoinformation, basically location intelligence. You might not be able to read it from there, but I'll walk through a few of these things. So very early, sort of the technology trigger area, we've got georobotics. Robotics related to location in space and time. Spatial knowledge infrastructure. Oh, sorry, I forgot to mention. This is 2018. So location intelligence is moving very, very fast. So a lot of these have moved up this curve fairly dramatically. I would claim, for example, that location-based machine learning is right at the top of it, and maybe it's certainly at the peak of expectations, I would say. You've got 3D printing, which really hasn't anything to do with this. Smartphones, that's with new sensors. I can tell you, for example, with respect to new sensors, I was there in Australia. I'm chair of a research organization in Australia. I was there when they managed to get GPS accuracy down to 2 centimeters. Can you imagine what a 2 centimeter accuracy on your GPS would do? Think about what you do with that. I mean, you could literally put a GPS at the front of your car and one at the back of your car and know which direction you were pointing. You could put one at each end of your phone at 2 centimeters. So pretty dramatic. Of course, that's not commercial yet because the surf chips that support GPS, they still have to pick up on this technology. It's not there yet, but it's pretty dramatic. Autonomous vehicles, indoor positioning. Indoor positioning is a huge opportunity, or I should say problem/opportunity. Indoor positioning is quite difficult, and there are lots and lots of interesting solutions for it. The one I find most fascinating is the one that uses LEDs, actually the LEDs that light, and they emit a particular frequency of sound, and your phone can pick that up, and it can triangulate from the different sounds that it's picking up where it is indoors. I think that's quite clever. Smart cities are down here, and I would claim that smart cities have already progressed quite a bit. I think smart cities are probably in the slope of enlightenment by this stage. Big data is climbing out. Location-based services, there's a great one. Isan can tell you all about location-based services. We have a few of those already at RBC, and we'll be building lots more. And I think that's all. LiDAR's in there. I should probably mention LiDAR just so you know what it is. Is people familiar with LiDAR? Probably from autonomous vehicles. Yeah, it looks like. We were just looking at an example this morning, a small example of LiDAR data that was picked up at 1 centimeter accuracy, 1 centimeter separation, 6 billion points. It was sampled in 1 day with a machine that samples at 1 million points a second. So when you get that kind of detail, you can pick out nose hairs. So now you might ask, now we know what location intelligence is. Now I've put my foot on GIS and scrunched it into the carpet. What can we do with location intelligence, and why is that relevant to why is that relevant to RBC? 2 years ago it wasn't. We joined 2 years ago and we set up the location intelligence team. Now it's throughout RBC. Just about every division, every business in RBC has an engagement in location intelligence or is using it for some purpose, or is in the process of talking to us about how to use it. So I'll give you a couple of examples. So I mentioned earlier that we do climate analytics, that our team does all the climate analytics for RBC. So on the left-hand side here, these boundaries here, the red boundaries, that's the furthest extent of the Fort McMurray fire. Remember the Fort McMurray fire? Just a devastating fire. And these dots in here are the locations of RBC customers. Now I've left, you can see the green ones here. They're the ones that were perfectly safe, had no consequences from the fire. These are the people who are affected by the fire. So immediately, if we hold mortgages there or we have insurance in that space, that's of immediate impact. And you can imagine the other catastrophes. So the Quebec, the floods in Quebec on Easter Friday. We saw the floods about to happen. We have a prediction mechanism that we can predict where the floods are going to be and what the boundaries of the floods will be. So we predicted floods. In 24 hours, we did the analysis, we did the prediction, and we built a website that showed which RBC facilities were going to be flooded, which RBC facilities would be affected because people couldn't get to them because the roads to them were flooded. We did all the businesses that were customers of RBC, exactly the same 2 pieces of information, and we did all the customers of RBC who are in the same situation, who would have challenges getting around or were going to be in the flood zone. And so what our commercial managers did with that data was they went through and found all their commercial customers and they called them and said, our analytics team is predicting that your business will be impacted by floods. We suspect that your balance sheet in the next quarter might be affected by that. Be assured RBC is here for you. That's an amazing strike I mean, where are you going to go for your next business loan? It works. On the right, we've got, this is the flood data from the floods in Ottawa. It may not be particularly easy to see, but there's a bunch of red dots in there that are customers of ours that have been affected by the floods. We don't just do disasters. We can also look at things like where are customers moving in space and time. And I'll come to that in just a bit. We have a problem with location intelligence that there really isn't a product. So we're getting to the meat of the problem here. There isn't a product, and that's compounded, as I mentioned earlier, by the presence of complex GIS products. Because there is the tendency to say, well, I've got a map, so now I'm going to bring all these GIS operators into play. And you remember that bar that I showed you there with all the operators. Well, actually, that's not all the operators, it's just some of them. So how do we put this together in such a fashion that it is usable by everybody in this room without doing a 3-year course in GIS? How do we put it together in such a fashion that the artificial intelligence aspect of this, the machine learning aspect of this, is neatly integrated? And I can guarantee you there is not a product anywhere in the world, open source, closed source, or in private hands, that puts machine learning and location intelligence together in a single product. Guaranteed. As I serve on research organizations all around the world in location intelligence, and we would have seen it if it was there. Something to think about. Okay, let's talk a little bit about what that location intelligence product might mean to us, how we would put this together, what the challenges would be. The first one is location intelligence operations are typically big. So there is a project that we've executed that took all of the customer locations of RBC customers. And to do that, you use a product. You use a technique called geocoding. Geocoding takes, it's actually fairly simple to explain. It takes an address, whether it's a miserable address or it's a clean address, and it produces from that address a rooftop XY coordinate, and it produces a bunch of attribution that belongs to that. Now, the process of going from a clean address to a location is relatively straightforward. That's a lookup, right? But to get the clean address is a challenge, and I'll give you an example of that challenge. As somebody's nodding, obviously has encountered this problem. The nightmare is the ugly address. And I'll tell you a story about RBC. So when we first joined 2 years ago as a location intelligence team, somebody came to us and said, I've been working for 3 months to try and clean up my address list. And I've heard that you guys have some techniques that you can use to clean these addresses up. And we said, yes, certainly. How many you got? 90 million. Not 19 million, 90 million. I said, okay, let's get rid of all the international ones. Already did. Oh. So what about the duplicates? Yeah, done that too. So I'm thinking to myself, there are only 14 million addresses in Canada. How did he get to 90 million? There's an awful lot of really, really bad addresses in there. In fact, we found things like inside leg measurement 34 inches, right? That's not really an address as far as I can tell. We found really strange stuff in there. Interest rates were in there. So we said, okay, let's run this through our cleaning process. We ran it through the cleaning process, and that's where we came up with our 12 million addresses. 12 million unique, clean addresses, which is an astonishing number, if you think about it. Because if Canada has 14 million addresses, 12 million of those addresses we have a customer in. Okay, we've got some high rises that change the numbers, because the high rises are going to have a single address and there'll be lots and lots of inhabitants. But even so, if you think of it in a spatial sense, in a location sense, that means our penetration across Canada is second to almost nobody. It means that literally every little hamlet, every little area, every road in Canada that has residents on it, we have customers there. So we said, okay, what can we do with that? It's incredibly useful information. Now, I'm telling a long story. I'm still on point one here, just in case you're trying to keep up with this. So one of the things that we thought was, we have intense detailed financial data about every one of those 12 million people. We know loans, we know credit card expenditure, we know a lot about their financial behavior. So we could actually build a set of polygons that for each polygon there is a homogeneous pattern of financial behavior. Now that's called Voronoi tessellation. And we did it multivariate. So we used multiple variables to calculate what this polygon fabric across Canada will look like. Multivariate Voronoi tessellation. So you can imagine that's a big compute problem. That's not something you go, okay, start, and then 5 minutes later it's done. That's an enormous, enormous amount of compute. So our location intelligence product has to be able to handle length of operations. So you have to have a truly elegant way of shutting down your desktop, letting it run, and reconnecting with it when something happens. So that part's a problem. And how do you explain to your user, oh, this is going to be going for a week. Come back in a week. How do you keep track of it during that week? They're all straightforward computer problems, but the product has to be able to do this elegantly, because it's going to happen a lot. The second one is massive parallelism. The only way we're going to get some of these huge compute problems dealt with is if we've got lots and lots and lots of parallelism. So I'll tell you another story here. So you go into Longos, let's say, let's pick on Longos, and you execute a transaction in Longos. Think of this as if this was you. You pay for it with your credit card, and a millisecond later, RBC knows all about it. And then you get in your car, and you drive to Home Depot, and you execute another transaction. So we know the time when the Longos transaction happened. We know the time when the Home Depot transaction happened. We know the time difference between them. So with pretty high precision, we can guess what path you took to drive between the two, because we can do a drive time. So now imagine every resident in Canada, well, at least 12 million of them, who are executing those transactions. That means literally for every road segment, every little road segment in Canada, we've got a proxy that estimates the appetite for spending of people when they pass that at a certain time. So imagine computing that. So that's where the parallelism comes in. So it absolutely has to be massively, massively parallel. It's the machine learning problem all over, except now the machine learning problem is big, the location intelligence problem is big, the combination of them is gigantic. Make sense? Don't panic, I'm going to stop at the end of this for questions. Size of data. This should come as no surprise, but spatial data is huge. So why is it huge? You think, well, it's just XY coordinates. Well, it is XY coordinates if you're only dealing with points. But as you saw from those maps, we've actually got polygons. And we've got quite complex polygons with lots and lots and lots of really little vertices around the edges. We've seen polygons that were coverage patterns from Decibel Planner for mobile phone coverage that had millions of vertices per polygon and millions of polygons. So the data gets really, really huge, and it's generally a bad idea to be shifting that data around. Now you're going to incur all kinds of latency costs moving the data between compute resources. And the final one is, visualization. As Asan will tell you, the process of visualizing this stuff, you can draw a map, and you can draw some of your layers on top of the map, but very quickly you wind up with such a clutter that you have no idea what's going on the map. Okay, so now add in some graphs, and let's put some more tables over here and some graphs over here, and then we need a legend over here, and very quickly you've completely lost the point of the visualization. That was always the problem with the GIS systems, was that you would get so much clutter, you just go, I have no idea what this is telling me, get rid of it and start again. So I am going to pause momentarily in case there's questions or comments. Yes, sir?
On the challenges, isn't it a challenge to have the most updated data of locations? Because
oh yes, actually that's a really good point. Do you want? I should put that on the slide. Well done. Yeah, yeah. Currency of data, but it's even worse than that. It's not just currency of data. It's mismatched currencies. So we have transaction data that just happened, and we're trying to relate that to something that might be a year old. Oh, I think I'm going to get sworn out for not standing in front of the thing here. So it's not just that the data might be out of date. It's that the data might not match the other data. Another problem that we deal with constantly, and I probably should have put that on the list as well, is that the accuracy of the data varies. All right, so we get a very high precision geocode right to the center of the rooftop of the house. But the geodemographic data is associated with the dissemination area that holds 1,500 houses. So how do you resolve the two? Yeah.
There was a point here.
Yes?
Yeah, you mentioned, without having to train for 3 years in GIS. I mean, some university and colleges still offer specialized or specializations in GIS.
They do.
So are they purely only teaching you how to use GIS software, and can you actually go from not knowing that, complex projections of Earth and curvature of the Earth, and can someone with good quality geocode data and just good product development can build a complex enough location intelligence product without having no prior knowledge of that?
Absolutely. Absolutely. I'm convinced that's possible. So to answer your first question, yes, there are still universities and colleges out there that are teaching a GIS course. I'm delighted to say that there are courses now in Canada that have switched over to teaching from the standpoint of location intelligence. They're not necessarily always called location intelligence. The one I would plug is Ryerson. They have an MSA, Master of Spatial Analytics, which is location intelligence. I helped them write the curriculum for the course, but it's now heading in the right direction. I think there's a few things in there they could still leave out. But you're absolutely right. The cool thing about location intelligence, if we get it right, and we get a product that actually works, that's maybe a week familiarization. We can bury the traps. The classic one you just pointed out, projections. You really don't need to know Snyder's text on projections. You don't need to know that. As long as you've got good geocodes, your coordinate system is consistent, you're good to go.
Yeah, I mean, doing the Haversine distance versus the Euclidean distance could impact your analysis, but I would think, depending on the precision you're after, it's probably not going to matter for your use case.
Yes, and in fact, I would hope that people don't even need to know what the Haversine distance is. Right? Yeah, it's a good point. Anybody else?
Is keeping all the location information secure, is that a challenge?
That's a great question. I'll give you the $5 later. Keeping it secure at RBC is not a problem. Actually, getting at it at RBC, that's where the problem arises. No, that is definitely, because the firewalls are, you're completely covered. But you do have a good point in that less rigorous players could draw inferences that perhaps they shouldn't.
Exactly, because the bank I am currently using, they need my phone location so that I can use my debit card or ATM. So
do they?
Yeah,
what's that got to do with your credit card?
Just to make it secure. If I'm in the area, I can go to the ATM, and that's their way of cross-checking.
So you're asking a really good question. So
that's a good thing, but there is a big bank. But if a small bank was doing that, I would be really concerned because they would be accessing my location 24/7.
You're exactly right. Yes. Yeah, that's we have a policy at RBC that if you use an RBC app, we do not collect your location. And that's a decision from the reputation team, and they just said, no, we're just not going to do this. That's why we use the transaction data for research. But the transaction data is less intrusive. It just knows the behavior after you've completed it. It doesn't know the behavior exactly as it's happening. Yeah. And we can secure it with all kinds of, yeah.
Would you like to take a question from online?
Absolutely,
Yeah.
yes.
The question is, with such a huge amount of data, what is your backup strategy?
Oh, that's an interesting question. I'm not the I'm not under the I'm not the TI guy. The IT folks could probably answer that better than I can. But basically, the backup, it's got to be a parallel backup. It has to be. We don't necessarily do, whoever that is, we don't necessarily do DR on the location data because the transaction information already has DR. I'm talking to the microphone like it's a person. Yeah, we don't necessarily do, because the base data that we're working from is all DR, so we don't worry much about that. Backing up the inferences, though, we definitely do that, because if you're going to compute for a couple of weeks on something, you don't want to lose the results. So that's definitely backed up. Any others? Yes, ma'am.
Can the type of information you collect be used to identify fraudulent purchases?
Absolutely, yes. Yes, that's a very good one. A classic example would be you execute a transaction in a place where you've never been before and you've never transacted before, and we have it in our database as an area that's suspect. Yeah, so definitely.
I was also thinking, like, users can build a profile of their routine purchases, like along goes, and then, you know, the example you brought up, and then if something is outside of that time frame or the usual locations between, you know, a weird hour, that could flag a
Absolutely.
potential, you know, threat.
And that's our advantage with having those transaction paths, right? So understanding those trajectories in detail, you can very quickly spot an anomaly. Something very strange has happened here. This does not fit the pattern.
So RBC does that right now?
We are almost there.
Oh, cool.
The trajectory stuff is all working, but actually getting the information back to a consumer, that's not done yet.
Cool. Thanks.
All right, let me press on. How am I doing for time, Amir? All good? So let's go after the location, and I've set the problem up nicely here, so let's go after the user experience, the user interface, and the user experience. So these are things that we believe are really important for a user interface, for a location intelligence product user interface. The first one's progressive reveal. So as you saw in that little bar that I had up earlier, that's not progressive reveal. Let's dump everything on the user and hope he can figure it out. The idea behind progressive reveal is you only show the user what the user is comfortable using, and you let the user discover nuances of it. Apple made themselves quite a reputation for doing progressive reveal in some of their user interfaces. Unfortunately, that's gone a bit by the wayside recently, but the original idea was you just had an incredibly simple user interface, and as you explored it, you found more and more things that you could actually do that were not immediately obvious to the beginning user.
Therefore, would obstruct their learning.
Exactly. So they just use the product and then go, oh, well, I wonder if I could turn those symbols red, right? And then a little bit of investigation, you discover that you can actually do that. Yeah. Progressive reveal would be one. Explanation of results. Everybody, I think just about everybody in the room has some machine learning, if not expert machine learning skills, and you know that explainability of a model is a really important aspect. It's no less important for location intelligence. You need to be able to say, the reason that I believe your property is going to be flooded is, you have to have some explainability. You have to have some rationale that says, yes, it's not like, trust me, it's going to happen. Also, if you've ever used a GIS tool, you know you have to click on this, and then you have to click on this and drag this down, and then you slide across here, and then you do this, and you enter these numbers in this menu, and then you move across here, and then you click this, and it happens. Well, I think that's a bunch of nonsense. that's you want a short path to the execution because you know what a user is going to want to know. So you hit that path quickly. Every GIS that I've used has the capability of being programmed. And there's Map Basic, there's a lot of them use Python, there's various hosted application capabilities that extend the GIS. My claim is that if those are there, we should learn from that and make those easily available instead of having to go through the process of the script. Delays in execution, I already mentioned that. You know, the execution takes a long time. Detached compute, actually we'll come back to that because that's a little further on. And I'll give you an example. Google Maps. I bet everybody in this room has used Google Maps at one time or another. And what's the first thing you notice? The user interface is incredibly simple. So I happen to know the guys who worked on Google Maps. And their most rigorous development controls were around the user experience. They could have put all kinds of interesting stuff into Google Maps. But their design decision over and over and over again was, no, don't put it in. No, don't put it in. Now, just recently, they've made some changes. You probably spotted some changes in Google Maps, which I think has broken that mantra. But the original mantra was simple, 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 and it has to stay simple. And every time we think to add something in, we've got to think about reasons why we would not put it in. So I think that's a lovely example for us. Think about what you absolutely don't need. Okay. Hasan and I talked a little bit about what we talk about here. Unfortunately, there's quite a few. This one here and this one here and those four over there, we can't talk about because they're all it's going around. First of all, him, now you. Watch out, everybody. It's on its way around. Yeah, so those we can't talk about, unfortunately. In due course, we certainly will be able to. But these ones we can talk about. So the climate change analytics, fairly obviously there's an opportunity for machine learning there. And that is in terms of prediction. It's in terms of understanding the nuances of how the weather is influencing things, but it's also in the way that it looks at how businesses are behaving. So fairly obviously that's a big one. I used to run a team way back when who did site selection. And site selection is the process of finding a new facility for an expanding organization. We did site selection for Home Depot, for Lowe's, for Tim Hortons, for just list out the top 100 retailers in Canada. We did them all except Walmart. Walmart had their own site selection process. At one point, Home Depot was opening a new outlet in North America every 48 hours. Breathtaking expansion speed. So we opened every one of those. We also told them what to put in the store in particular areas. Anybody been in a Home Depot down south? Did you notice the hurricane aisle? Did any of you notice the hurricane aisle? You might not have been in the hurricane path, but all the Home Depots, this was our idea, all the Home Depots that are in the potential path of a hurricane have a hurricane aisle. And the aisle is wider, and it has things like generators and sheets of board and tarpaulins and flashlights and batteries and chainsaws and things that you would need to rush down the aisle and grab when the hurricane was coming. So that site selection process, as interesting as it sounds, was still relatively primitive. It was still variables. It was still human judgment. We are more than convinced that site selection now would be very well suited to location intelligence combined with AI. And recommenders. So a recommender based on location. So folks, underway, people moving have different behavior. For example, you entertain an offer from an organization differently on the GO train than you would at work. And those differences are very important from the standpoint of location intelligence. In fact, it's we say at RBC that location is the best estimator of human behavior that we actually have. And I think that's very true. So where you are conditions your behavior. And this was, I think we're almost at the end here. Now I mentioned earlier that the spatial data is immense. An example of that was I was challenged in New Zealand, I think it was. Yeah, it was New Zealand. And we'd just shown a spatial database that we'd built. And it was a database with spatial extensions that had spatial types and it had spatial indexes. And this was before SQL Server had spatial extensions, before DB2 had spatial extensions, before Teradata had spatial extensions. And we were challenged, and I was saying, well, we can store almost anything in this spatial type, single row. And somebody said, well, do the New Zealand coastline. So this is the New Zealand coastline with all the little crinkly bits, millions and millions and millions of points. So he wanted that in one row. So you imagine what that blob looked like. It was brutal. Everything worked. So I'm pleased to say it you know, my ambition was satisfied, but it just the size of this thing was immense. So if you wanted to process that, for example, you wanted to see what a sea level rise study against the North Island of New Zealand would look like, you would need to do processing on that. So the way that we need to be able to do this is what we've been calling ephemeral computing. So the compute piece moves to the data as opposed to the data moving to the compute piece. And as the compute piece moves to the data, it produces a result set and then vanishes. I mean, it exists in today's computing, not necessarily named as such. But if ever there was a case for ephemeral computing, location intelligence would probably be the best one. And it's time for your break. Just before we dive out for the break, are there any further questions or comments? Yes, sir.
I couldn't really get the complete intuition on what exactly you mean by moving the model to the data and the data being moved to the model. So my intuition is not complete, so
right.
I need your help.
Right. So I'm not going to go into too much detail, but the notion is that where the data is where the computation happens. So a very simple, this is a ridiculously simple example, but we bury spatial operators. Let's say there's a spatial operator that's called buffer, right? So an example of I give you an example of buffer just so you know what it's about. Truck travels from Ottawa to Toronto, but it's carrying something dangerous and it's leaking. So it's leaking onto the road. So as it leaks onto the road, it spreads from the road, and that spreads and spreads. That's called a buffer. It's also called a plume. But computing that along the length of the road is a buffer operation or a plume operation. So if we pull that road from the database and operated it on it outside, then we'd have that plume to put back in, and we'd have that whole road segment outside that we'd have to carry in memory somehow. If we do it right inside the CLR, right inside the database, the results are right there. So the compute has come to the data, and the compute disappears, but the data remains. Make sense? That is a very trivial example, because we actually want to transport units of code around. That ultimately is how we want to do that. Any others? Questions, comments? Yes, sir.
Might be like a little bit distant from like the actual topic, but you said at the beginning that most of these tools are like just owned, in this case, by RBC, right? However, things like climate analytics can be used to, let's say, predict where a flood can happen and stuff like that. Is there any interest to make a part of this open source? So let's say governments can take advantage of this to predict, like see where to take resources to rescue people. Or something.
Absolutely, absolutely. It's a great question, and yes, absolutely. Although I would go a little further and say that in some cases RBC would probably be willing to do the analytics for certain organizations. So, and I'll give you a great example. We just did a study for Red Cross where we did, remember I talked about the multivariate Voronoi tessellation. So we actually analyzed Canada into tiny little polygons, and each of those polygons is a homogeneous estimate of the financial vulnerability of its population. So Red Cross can now say, you get $10 and you only get $1, right? And there's a very logical reason for it. So we actually did that for Red Cross. We could have just given them the operations, but we did the whole thing for them. So yes, it's a great example, and I'm sure somewhere along the line we'll contribute open source. I have a personal preference for doing some of those analytics ourselves, because I'd rather it was some kind of a community, but we'll see how it turns out. Any others?
So for explanation results, so I was wondering what kind of models do you use?
For explaining?
Explain like explainable AI or practical. White box models?
Would you like me to take that?
Go for it, Hassan.
I'd say so the piece on explainability is very similar to any other. If we're talking about AI algorithms, very similar to other AI algorithms, but mostly concerning spatial AI algorithms. So think about CNNs, transformers, because we deal with an extensive amount of tabular and imagery data. So I can add more. So like if you
we can talk that offline. It's okay.
Yeah, but if you look at a deep network, for example, CNN architecture, you can access the receptive field, but do salience testing to see what happens. Yeah, but more I can talk about.
Yeah. Cool.
I think that might be a to-be conversation.
Yeah, to-be conversation. Yeah.
Can I suggest to go to break and then come back?
Absolutely.
Fantastic.
Excellent. So these are the takeaways that I wrote, but I have a suspicion that folks in the audience have probably got some takeaways that aren't on that list. So I'd love to hear from you, and it's probably a good spark for a conversation. But I'll run through them real quick. It's our experience that location intelligence and machine learning go hand in hand, and it's extraordinarily rare that we have a pure location intelligence model or a pure machine learning model. Quite very often those two intersect because we've got such good prediction from location intelligence, and we've got so much skill in the machine learning space. As I explained, the location intelligence product, if we were going to put it together, would have a brutal problem in the UI UX environment, and that would take extraordinary thought. In fact, you might hypothesize that we should use machine learning to generate the user experience, because that way you can iterate until you get something that works. GIS has reached saturation and is in decline. GIS is now used by US government to produce their data. It's used by various organizations around the world, mostly government organizations for that. And for that it works because they script everything and they've got established practices. But for the small business, beginning user, this is not a space that you want to occupy. And location data, it's everywhere. So I have to tell you a little story about that. We did a little bit of a study early on, actually this is even before ASUN's days, of the data that the bank holds, just a survey across all of the various data sets. And trust me, it's a huge data set. I think it's recently estimated at 69 petabytes of data that we have available for analytics. That's not a trivial amount of data. But 92%, as best as I could estimate, 92% of that data has a location aspect. And if we don't take advantage of that location aspect, then we're losing an enormous dimension in our data. So we've thrown together some discussion points to get the conversation underway. These will take a little explaining. The first one, challenges seen in the location intelligence product. Example of an AI location intelligence hybrid product that you would like to see built. And I don't mean here the location intelligence product, I mean something that uses that to produce a result. Where would you like to see this being used? And this needs some explanation. What is an XML? So when ASUN and I were putting these slides together, he said include some XMLs. Obviously he meant examples, but so I thought we better figure out what an XML is. All right, and I think that's me. Yep, here we go. Handing it back to you. Yeah, what is an XML? We did Google what an XML is. It does exist. It's a thing.
If you want to know more, ask. And then I'll be obliged to tell you.
So maybe the facilitators can talk a little about their experiences.
Yeah, so you touched a little bit about accuracy of XY and 5 centimeters. And I think any location intelligence product, it starts from there. And I think you need to define what precision of geocoding are you okay with? Are you okay with an 80% solution, or is it you need to go granular? Because if you go more precise, then it costs a little bit more. And I think you have to figure out what are the trade-off in chasing that higher precision of geocoding. Because when you try to embed machine learning within location intelligence, then precision kind of becomes important. I mean, if I'm trying to predict the price of a house based on its neighbors, then it's important for me to know how far those homes are from me. That's just been my experience, and for me, I was okay with sort of like, 80-85% of my homes being within 50 meters of the house, and that gave me a pretty good solution. But I think that is important for you to figure out, and you need to figure out, is that a problem that you need to outsource or you need to build yourself? Because as Arthur mentioned, addressing is a very complicated and dirty problem that you might get your hands dirty with, but might soon realize that is not the problem you want to solve. Is what I've found. Because it then becomes an entity resolution problem, and it needs to be database backed. That's just been my experience.
So just to attach on to that, I did say earlier on in the presentation that you have to be careful when you're combining data sets of differing temporal estate and of differing accuracy.
Mm-hmm.
So if you've got extraordinarily high geocode precision, as we do, pinpoint right in the center of the rooftop, but the other data that you're joining that with is of much coarser state, the combination is only going to be as good as the coarse data set. So you have to realize that you can't attach lots and lots and lots of decimal points to the result, because it just doesn't make any sense. You've lost the precision by doing the join to inaccurate data sets. So that's one to keep in mind. But if you can stick with addresses as your join factor throughout, then you can keep that precision, and it can be quite high. We use so our rooftop geocoding and their rooftop geocoding, if it's the same geocoder, that gives you a beautiful join.
Anyone else has something?
I can talk about the, a bit of examples of AI products that I can talk about, more public.
The ones that aren't on the blank part of the slide.
And the one that hopefully aren't on the blank side of the slides. I remember two use cases. So one, for example, working in geolocation intelligence team, and we deal with climate challenges, be it global warming, extreme weather, so on and so forth. And an AI, an intersection would be now there are tropical cyclones, as well as atmospheric rivers, good predictors, both extreme events and good predictors of extreme events. The size of the data is massive, and even something about a temporal resolution of 3 hours. These are satellite imagery. Would require a compute of hundreds of petaflops, right, which would peak at exaflops. So would go more than 1,000 petaflops, which is kind of groundbreaking in compute these days. And the only way that we can do this is because of cloud architectures. So you see an intersection between cloud computing, and AI. The AI comes in where if you have such and such images, can you tell which parts of it are tropical cyclones? And on that resolution, can you actually predict where it's headed? Right? So that was a very interesting use case. That's public domain research. If you're interested, you can take a look at it. Recently, there may have been some debate around a hurricane. Was it? Would it hit a city? Would it not hit a city? Some people would say something. Other people may have said something else. But that would easily be able. So on
one group of people was wrong.
Some people may have been wrong, and then anyhow. So that's something with historical analytics you can discover, and with predictive analytics you can actually show that within an AI model that this is where it's going with such and such likelihood. That was an interesting, I believe, AI application and intersection of AI and geolocation and cloud computing.
Anyone else?
Just about the project, do you have any idea of the different inaccuracies between, let's say, fluid dynamic models and AI models?
Yeah, that's a very good question.
That's a good question, yeah.
That's a very good question. So
next.
Next. That's an amazing question, and that will open up a great can of worms that we're more than happy to talk to you about. So basically, AI must be used. I would argue where you can't dynamically predict. So if you have ways of predicting a behavior of a fluid, whatever it is, almost deterministically, then you do not need AI to do that, right? And now in a lot of cases, we do not have that resolution, say mostly unstructured data, right? But for cases where we do, maybe it's not the best use of AI. So I did not see a convincing argument as to why we should use AI. There was, in such studies, there was one argument where it said it actually, so they trained it on a CAM5 model, if you're familiar with it. That's a dynamical system model, and that already lost me, because I was like, well, if you have already a dynamical system, why would you train AI on top of a system that's already faulty? And the answer is you don't. You shouldn't do that. But the claim that blew me away was that they claimed that the AI in some cases worked even better than the dynamical system. Now, being it was the ground truth, that even further baffles me.
So there's a footnote to that I can add. Spent some time with a team of weather analysts. I can't tell you where they were, but specialists in fluid dynamics. And their contention was that the weather system, or the consequences of weather systems, are a fundamentally chaotic system. So there's a reasonable chance that an AI might do a better job. This was their prediction. There's a reasonable chance an AI might actually do a better job of figuring out the weather prediction than the various complex models that we write. Because as fast as you write the model, something chaotic happens, and you've got no predictability from it.
Interesting. That's a very interesting point, because in AI models, there are ways to inject noise and stochasticity into the system. Yeah. I'm not sure if you would do that in fluid dynamics.
No, actually, you'd be limited by the size of the cell in which you're running the equation analysis, right?
Right.
So one thing that I heard once from a professor DOT was that one limit that you have, let's say in the Canadian prediction system for weather, is that there's not as much computational power as you have in the US, right? So models here are tend to be a little bit more broad, non-exact as in the US. I don't know how true that is, but yeah, it's always governed by how much computational power you have behind running the model, right?
I guess there's also the timeliness, right? That's another issue. I remember a chap from University of Chicago who did this brilliant traffic model. Again, a somewhat chaotic system. And he was modeling rush hour traffic and rearranging the traffic and getting new routes for people so that he was breaking up traffic jams. The only problem was that the model took 24 hours to run. So by the time he had the results, it was the next day's rush hour. But timeliness, right? That's another aspect of it, right? We can't compute that in time then.
Yeah. Again, with AI systems, there are ways that you can build sparse models where you can capture most of the pattern. Now, arguably, on the complexity, depending on the complexity of the phenomena, it may not perform as well, but there are brilliant ways, actually more often than not, making models smaller in a certain way may even improve the performance of the model because of the injected noise. That also blows me away.
Yeah, that's pretty cool.
Very interesting, yeah. We had a very, on the technical AISC series, we had a talk about, I believe, digitizing words with much less
Word to bit.
Word to bit, yes. So just Google that and say, was it AISC called back then? It was called TDLS. Check out our website, you'll see. Word to bit, and check out the website, or search that on the website. And then you see, that's exactly what I talked about just now.
Thanks.
Yeah, absolutely.
So when you are trying to build a solution on the geodata or a spatial data, I hope you will end up with at least hundreds of features, if I'm not wrong.
Depending on the problem.
Depending on the problem, right? So if your business objective requires the explainability, how do you do the feature selection? Because for feature selection, part of the algorithms you have in a mathematical base, and you end up with using mathematical transformed features, while you look for a specific set of features to be extracted, and then you build a model.
Yeah.
So if you do it, you lose the explainability, obviously, right? And if you are sticking to the explainability, you are left with a little model, little algorithm. So how do you solve?
Yeah, so right now we don't really much transform raw features.
Oh.
In fact, I'm a proponent of deep learning methods, and I am known for at least trying to convince the business that it's very explainable. But there are two categories of models that are mostly used. One are decision tree models and regression models. They're very, very explainable. With decision trees, you do not have to do anything with your features. You just look at the information gain and then rank your features accordingly. With deep models, use these methods called saliency testing or salience testing. That looking at the receptive fields of a CNN, for example, is a simple sort of version of that. And then seeing there are multiple ways you can probe your network, and basically see what are the values, the input values that the network is paying attention to when it wants to make such and such decision. So now, correlation is not causation,
Of course.
but it provides some degree of explainability, arguably the same level that you would see in a regression model, which sucks, and a decision tree model.
So I think I can ask multiple questions, right?
Of course.
Okay, thank you so much. So obviously whatever you are predicting, you predict with a certain amount of accuracy, right? So when you submit your predictions to the business, for them to go ahead with an actionable steps, I mean, they obviously like to have more certainty in the results. So what would be the benchmark cutoff? Generally they accept it, because I worked on the solutions, like they said, like, we don't like your solution because your accuracy metric is like 90%, 95%. I know that varies from business to business, problem statement to problem statement.
Yeah.
But though generally on a thumb rule, like 90-95% is a decent enough, but business said, like, we don't like your solution.
Yeah.
So in this kind of solution, like in this kind of area, like GIS and all that stuff, so how exactly you try to convince the management saying that you can still go ahead with that, and what would be management's way of accepting that and taking it up ahead?
Yeah. So I'll talk a little bit to that, and then you feel free to complement it. So I think that the measures could be a little bit different over here, because we're talking about spatial metrics as opposed to only accuracy. So if you're within some radius, it's acceptable. It's again, I know you don't want to hear this, but it is really variable between different tasks. But if given a problem, let's say you want to know where I don't know where a Home Depot location is. If you're a couple of blocks off, maybe you're forgivable, but maybe that's that's fine. But if you're at like a complete neighborhood off, if you're that's not okay. Usually, I think the Tom's rule for other types of machine learning, usually if you do 80%, given everything is balanced, because accuracy can be very misleading. But if everything is balanced, if you get 80%, it's usually business friendly. But for some cases, I don't know. Depends really what. Some cases false positives are such a big deal. For some cases, false negatives are such a big deal. So given those, then we define our metric, and then we try to satisfy basically given the risk appetite of the business we talk to. So that it's highly variable.
We had a modeled example that we used. Remember, I talked about the floods, the Easter Friday floods, and so we were predicting where the flood would be and predicting who would be affected by the flood. And we only really had to wait about 4 days to see how well we'd done. And that was pretty convincing to the business, because we were very, very close. I think a very small tiny single number percentage out. So examples like that are easy because you don't have to wait too long for validation, unfortunately, for the people who got flooded, but we didn't have to wait long for validation. And another thing we've done is prediction from history, right? So we say, okay, let's take, because we have 10 years worth of data, let's go back 5 years and predict the 6th year. And, you know, it's a confidence boost. It doesn't guarantee that the results currently are right, but it's a confidence boost that the mechanisms are pretty right. Anybody else?
Did anyone come up with any interesting ideas when you were having the breakout discussions? Any concerns, use cases, privacy concerns? Oh, there you go.
We were just talking about some other use cases which could be there for location-based intelligence products, mostly on the marketing side. So one of them was for a bank. You could just, I think you're already doing it, and that is where you would look at different areas and see where would you want to have your next branch, depending on the concentration of branches and people and demographics.
And behavior.
Yeah. And then the next is the product penetration. So depending on how product distribution is, recommending what products can be given to customers. So those are two use cases that you were talking about.
We get two. You go first.
Okay, so I might have like a scenario which is very specific to insurance, but so we do geocoding of risks, like addresses to geo variables on historic data, but sometimes our risk might move to a different location. In that case, like, can we in real time, like, you know, like adjust the model to like adjust the rates for the risk? So for example, I moved from Toronto to Fort McMurray, and I moved to a more riskier location. So will I be able to adjust the risk or adjust the rates for my customer based on real-time change of location?
Oh, for sure, yes. I thought you were asking the slightly more exotic question, that the fact that you moved to Fort McMurray influenced the patterns of risk in Fort McMurray.
It's like, how do I adjust the rates real time based on the risk moving to a
That should be absolutely easy, because you would have to have risk patterns predicted across the country, right? So if you moved into this little polygon, remember the little red polygon where people were affected by the fire? If you moved into that space, then obviously your risk profile has changed, because that history would go into the estimate of the risk for the area. Yeah, so I would think that should be absolutely possible.
I can add to that a little bit. I mean, in insurance, there's a lot of regulation as well. So depending on which polygon you move to, if you move farther in now, then absolutely your rating algorithm should be able to. So then, based on your location, then you'll be accessing that aspect of your rating algorithm, which obviously changes based on where you live.
But I do love the idea that you moving to Fort McMurray influenced the risk profile there. And as funny as that sounds, if you look at the number of people who moved there from PEI when the fishing industry in PEI collapsed, you could probably make a cogent argument that those people have actually changed the risk profile there. Yes, you had.
Yeah, I was just wondering what location-based behavior means, like the spending, expenditure, buying power, something like that.
Have you been to the X? No? Oh, that's right, you just moved here.
Yeah.
Yes. Well, think of it next year. We just missed it by a bit. Yeah, so I always use that one as an example. Because people go to the X and they buy things that in their right minds they would never buy anywhere else. And then they take them home and throw them in the bin. Right? But that's a case where the location has completely changed the behavior of the person.
Okay.
We're interested in the nuances though. not just the gross changes. The nuances are things like I said, riding on the GO train, right? You've got time, provided your neighbor's not reading over your shoulder, you can go and inspect things. And you know, somebody offered me this, I wouldn't normally be bothered with it, but because I've got a half an hour ahead of me on the train, I'll read this, right? So my behavior in general has changed, but even my behavior from an FI standpoint has changed. And as soon as I get off the train, couldn't be bothered anymore. Don't care.
Thank you.
So we talked a little bit about fluid dynamics and traffic. So it's always, I think the problem's already been solved. So Uber and Tinder has already solved the problem. But if we see a future where where shared economy is now the norm, so a product I would like to see built is, which obviously is going to have some AI component in it as well, where it's just tracking where you're driving at what time, and it's just recommending you drivers driving to the same location. It's helping you with the traffic problem. It hugely impacts insurance because you're just actually changing your risk profile completely of your book.
The one I would love to see is you're just about to leave town and it says, didn't you mean to go to Canadian Tire as well? That's the one I want.
Yeah.
The number of times I've driven away and gone, oh man, I meant to go to Canadian Tire as well.
Yeah.
Yeah, that would be, I wouldn't regard that one as creepy.
Yeah. I mean, carpooling has been around for decades, right? So I mean, it's just using technology to enable people to share resources,
Yep.
pooling together. I mean, I can imagine I work in Markham. I'm sure there's someone driving from my area to that office every day. I just don't know about it.
Yeah, and if they were,
So,
yeah, exactly. So
that's
you could ride pool with them, yeah.
It's a problem that Tinder and Uber has solved.
Has anybody heard of the Abilene paradox? No takers? We built, this is before IBC, my team built a solution for the Abilene paradox. The Abilene paradox is it's an apocryphal story. It's a bunch of people sitting around on a deck in southern Texas, and they're bored. It's a Sunday afternoon, they're bored, it's hot, dusty, people got nothing to do. And somebody says, let's go to Abilene. So they all pile in the car and off they go to Abilene for the afternoon, where they have a terrible time and an awful meal. And on the way back in the car, somebody says, I didn't want to go to Abilene. And it goes around the car, including the person that suggested it, and they all say, oh, I didn't want to go to Abilene. So it's an apocryphal story illustrating groupthink. Well, it's solvable with location intelligence. And the way we solved it was everybody who subscribed to the Abilene Paradox app, it was an app on a phone, everybody who subscribed to the app went on a website and they answered 5 questions. And we call them indicative questions because they key into a bunch of variables. And they're things like, where do you live? That's a very obvious geodemographic indicator. What kind of car do you drive? That's a powerful one. Sports events, there's 5 questions. And everybody answered those 5 questions, which immediately gave every participant an index. So now Ehsan and myself and Amir, and there's 4 or 5 of the rest of us. It's lunchtime, Tuesday midday, we're going for lunch. So we go down to the lobby of Water Park Place, and instead of the Abilene Paradox, where Ehsan says, let's go there, and everybody says yes, even though they don't want to go, you hit the Abilene Paradox app, which finds out who's nearby, figures out all those people, figures out their indexes, their choice indexes, searches the region for restaurants that match those indexes, and comes back and says, you people would like this restaurant best. Abilene Paradox solved. Nice little location intelligence problem.
All right.
Told you that story to provoke some more comments.
Those who haven't asked questions, your time now.
Otherwise, I'll go and sit on the GO train and entertain offers.
How does the bank measure impact attribution, especially with some of the physical marketing campaigns that you guys have around the city?
Yeah, I honestly could say I don't know. We work with the marketing guys from a standpoint of profiling and geodemographics and clustering, but measuring effectiveness of advertising, we haven't done anything with that. Asan, you ever got, of anything that we've done there? I don't recall anything.
Me neither. I mean, there are efforts that we're doing with some location efforts that we're doing with the place at Etobicoke.
Oh yes, yeah, but that's a different story. That's
it's not
I know what you're referring to.
It's very hard to measure. It's very, very hard to measure business impacts.
I think we can measure improvement. So if we had, so let's suppose there were dynamic signage, and we used our road segment profiles. And so between 9 o'clock and 9:30 on Tuesday mornings, it was about saving for your kids. And then between 9:30 and 10:30 in the morning, it was about home improvement. We could profile, we could have live advertising matched to the road segment that it's attached to. But actually measuring the impact of the marketing on, you'd have to ask our marketing folks about that.
Yeah, and a very constricted sort of set of problems or problem, then we can define it, but it has to be very concrete. That's usually we do, and we look at what's happening right now, be it revenue, whatever index we're using, and we implement it. So a simple way would be just A/B testing and see how we changed the outcome. But basically on very very concrete problems, we've got ways to define it.
Have you done anything with like geofencing some of the locations and tying down to the mobile app?
Yeah, remember the mobile app, we don't track people. Right? No RBC app picks up location. That's a policy decision, so we don't have that option. And actually, to be perfectly honest, geofencing advertising was tried, and I think it's pretty close to an abject failure because it's just so damn irritating. I remember using it I had a mobile phone in India. I remember walking down the street, and it's like bling, 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 and you go, oh, shut up! I know it's there. I'm not going in there. Oh, $5, whatever it was, off. No, I don't want any. I couldn't carry it home anyway. I don't need an iron gate.
Because of mass advertising, you probably get a few true positives.
So the end of that story though was the next time I was in India, there was virtually none at all. Yeah. They just turned it off because it was just so damn irritating.
Sorry, go on. I was going to say, I think I can talk a little bit about this because I work in a media company, and we did. I was involved before in a team that did marketing for Scotiabank. So like usually this kinds of attribution systems, at least if RBC says works with a media agency, is going to be done at the media agency and not by RBC. And usually what we do is what we call media mix models, which are like regression-based models that try to find correlations between, say, your out-of-home advertising or your social media and whatever the result that you're measuring against, whatever product you're trying to sell.
Good point, thank you.
On that note, let's bring this session to a close. I guess Arthur will be around for another 5-10 minutes, so come up and ask more questions. Thank you.